Okay, next we're talking about the local behavior of f of x, which is equal to 1 over x, which is the reciprocal function. So again, let's begin by looking at the reciprocal function. We cannot divide by 0, which means the function is undefined at when x is 0. So 0 is not in the domain of this function. As the input values approach 0 from the left side, becoming very small, negative values, the function values decrease without bound. In other words, they approach negative infinity. So let's take a look at what this behavior looks like in Table 2. So here we have negative 0.1. Okay, then it goes to negative 0.01. And then negative 0.001, and negative 0.0001. So you can see here that as we move to the right here, x is getting smaller and smaller. Now, what's happening with the outputs? Well, the outputs, it's also decreasing without bound. So that means you can see here that f of x, the outputs are getting smaller and smaller and smaller, going from negative 10, negative 100, negative 100,000 to negative 10,000. So we're going to write in the arrow notation. So what it's saying here is as x is approaching 0 from the left, the output is approaching negative infinity without bound. And again, we're using negative infinity or infinity because we're talking about without bound. Now, as the input values approach 0 from the right side, becoming very small positive values, the function values increase without bound, approaching positive infinity. So here, if we're using very small positive values, 0.1 to 0.01, 0.001, 0.0001, the outputs are getting larger. So they're increasing. So when we write as an arrow notation, we're going to say that as x is approaching 0 from the right, so it's getting closer and closer to 0 from the right here, we're saying that the output is approaching positive infinity. Now let's take a look at what this looks like in a graphical sense. Okay, so let's take a look at the figure here. Now you can see here that each particular situation has arrow notation. Now this behavior, okay, creates a vertical asymptote, which is a vertical line that the graph approaches but never crosses. In this case, the graph is approaching the vertical line x equals 0 as the input becomes close to 0. So let me go ahead and draw that vertical asymptote. So here represents the line of what I'm drawing here of the vertical line x equals 0. Okay, and that is a vertical asymptote. So that is considered a vertical asymptote. Okay, and again, what that means is the graph approaches that line, but it's never going to cross it. Okay, now we can also see here that if we take a look at the graph, meaning let's take a look at each particular scenario here. Okay, so what it's saying here is that as x is approaching negative infinity, okay, the function is getting closer to 0. So what it's saying there is as x is approaching negative infinity on the x-axis, well, the function is approaching the value of 0. Okay, now let's take a look at this scenario here. Okay, this tells us that as x is approaching 0 from the left, so it's coming from the left side, okay? So as it's approaching 0 from the left, well, the function is approaching negative infinity. Okay, let's take a look at this one here on this side. The function is going in this direction. So as it's going in that direction, it's saying that x is approaching positive infinity, as the function is getting close to 0, but never touching it, but it's getting close to it. Okay? And then if we take a look at the last one here, okay, as it's approaching the value of 0, meaning that it's getting closer to 0 on the right, okay, from the right, the function is approaching positive infinity. Okay, so again, this is how we're writing our arrow notation, and you want to be able to understand what each piece is doing on the graph. Now, we did say that there is a vertical asymptote here at x equals 0. But I also want to point out that there's also another asymptote, but it's a horizontal asymptote. Okay, and where is that horizontal asymptote located? Well, let me show you. Okay, you can see here that this line, I don't know if you can clearly see that, there's a line here that's the horizontal line, and that's the horizontal line y equals 0. And therefore, it's never going to cross the x-axis. So we also have a horizontal line, or a horizontal asymptote at y equals 0. Okay? So again, here is our vertical asymptote at x equals 0. Now, a vertical asymptote of a graph is a vertical line x equals a, where the graph tends toward positive or negative infinity as the input approaches a. So we write, as x is approaching a, then the function f of x is approaching positive infinity. So in this scenario on the right-hand side, okay, as x is approaching 0 from the right, the function was approaching positive infinity. Or as x is approaching 0 from the left, the function was approaching negative infinity.